Good morning.
Good morning to you. All right, I'm trying to figure out what we did here before. It looks like I have two tests that I've digitized in. Why don't we start with test 2, and then we can always go back for our last session and figure out if we need to. Test 1 is, or where we're at on test 1.
Okay.
All right, let's see. I've got everything right here. Let me open up my... Okay.
Okay, and on the first one, it can't be determined.
Okay. Let me see. I no longer have this book. And let's see what I have. I might have just an answered key. So, on some of them we might need to check, some others we might not.
Okay. On this one, quantity B would be larger.
All right.
And
Let's hope your test is like this. If it's like most tests, it's like most tests, it starts out easy and gets harder.
Yeah, unfortunately. This one, they're equal.
Okay.
And then
4.
Let's see, A equals, okay, quantity A is going to be larger, I believe.
Correct, because A, if you add these two equations, 2A is equal to 49, A is equal to 24.5. So B is a negative number. So 0, quantity B is larger.
Okay.
You see that?
Yes.
In other words, if we solve for A and then solve for B, we get B is negative.
You know, I feel like I need another number to solve this one.
Well,
no, I don't, because it's a isosceles triangle. Oh, well, I can.
this is the key piece of information right here.
Okay.
That X is greater than 90 degrees. So, how should we proceed with that triangle? It's true, it's isosceles. In other words, that's equal to that, and that's 5, so that's 5.
And that's going to be 5 root 2.
If it's a right angle.
Correct.
Okay, so that's what I was trying to get at, is the secret here is to figure out what that hypotenuse would be if it were a right angle 5 root 2 is a number that's greater than 7. Now, as x gets bigger than 90 degrees, what happens to this dimension?
That gets larger.
So, AB in all cases is going to be greater than 7. So 5 needs to be A. Let's just check that. Gosh. Let's see. 5A. I don't. Model test answer key. This is the quantitative ability. Question is it section 5 or is it section 3? I guess we'll tell by the answer to the next one.
Okay, in this case, quantity B is going to be larger.
Okay, what is x equal to? If you solve for x, what do you get?
Well, it would be root 5. 13 over 7, root 5.
Correct.
13 over 7.
No, that's right. Or if I want, I could write it like this. And how does this number compare to this number?
It's smaller.
Actually not. It's larger. And this is back to that same principle as to what happens when we take numbers that are greater than 1 or less than 1 and we take them to exponents. In other words, if you cube the number 1/2, what happens to it?
It does get smaller, 1/8.
Smaller. If you cube 2, it gets bigger.
Okay.
Okay? And the reverse is true. In other words, if you take a fraction and you take it to an exponent that is less than 1, it's going to get bigger because it's the opposite of this. In other words, this number that's less than 1, as we take it to a positive exponent, it gets smaller. So this one gets smaller. Now, since this is the opposite, it's the same number, but taken to a fractional exponent, it gets bigger. It's just like if I said, what's 1/4 to the 1/2 power? Well, that's the same as the square root of 1/4, which is 1/2. So this 1/4 got bigger. It became 1/2 when we took it to a fractional exponent.
Okay, that makes sense.
Okay. Just remember it always goes the opposite.
Okay.
So when we're comparing 13/17 to the 1/5 compared to 13/17 to the 5th, the key is this number less than 1 and is this number less than 1?
Okay.
Okay, I gotta go to the next page. Yeah, it didn't take them long to get hard, did it?
No, it didn't.
They gave us 2 or 3 easy ones just to get us warmed up. Can you read that?
Yes.
Some of these look very familiar.
Yeah, this one does.
It's almost like my sense is that they took their exercises and they just took certain problems and
Is the test questions.
did it on the test, yeah, which wouldn't really be good, but
Okay, now this one I'm trying to work it out. I've got that the area of both squares would be 144. And let's see, the area of this first circle, first one with the circles would be, let's see, the radius of one of those would be 6. So pi 36.
radius of one of them would be 3.
4. 3?
Well, there's 4 radiuses. We got a radius from
okay.
here to here, here to here, here to here, and here to here. Or we got 2 diameters. So each radius would be 3.
Okay, so that's 36 pi for all of them.
So that's the shaded area of figure 1.
Yes, and then the other one would be the same.
Okay, because there's 9 times 4 pi. Okay.
Right.
Interesting. Something about that bothers me.
Uh-oh.
No, I think that's the correct answer. It's just that if we took this to the limit, in other words, if we totally filled it up with small circles, would we see any gray area at all? And yet they're saying, yes, that would be this amount of gray area in there. I guess so. All right. Yeah, no, I'm comfortable with that. I was looking at it from a calculus point of view. Questions 9 through 20 have 3 different formats. Unless question has its own directions. Okay. I guess I've just never bothered to read that instruction before.
I almost never read them, which is probably not good.
Well, that was the standard one.
On this one, would I pick numbers?
You certainly could. It fits the description.
Okay.
I'm just thinking of, do we have to? See, this one I can see without picking numbers. But it doesn't hurt to pick numbers. Look, it costs just a little extra time. Give me a D, a P,
10.
and a T. T
We could say 2.
and P. And I think it's probably a good idea to pick different numbers in a situation like this. In other words, don't pick 10, 10, and 10, or even 10, 2, and 2.
Okay, 4?
Okay. So how many players are there in the league? If there are 10 divisions, each division has 2 teams, and each team has P players.
going to be 80.
How did we get that?
D times T times P.
Okay, so we can go straight there. So
Okay.
we don't really need to test each one.
Right, and we didn't really need.
Right, the only reason this I could see it was because it was all one thing, it was all multiplication. The moment you mix up multiplication and division, or even add in addition and stuff, it's much harder to see it, and requires, to me, to pick numbers, because I can do it when I pick numbers. I mean, I intuitively know the formula that I'm wanting to use.
Okay, so once again, pick numbers.
Sure.
Or can you see this one too? I can't.
I can see it. I can see it. But go ahead and
Okay.
do it in the most efficient way that you feel you can do it.
Okay.
If that's picking numbers, then you should pick numbers.
Okay.
In fact, it's probably safer, because I'm just realizing that the way I did it, I jumped to the answer. I'm 90% sure I'm right, but I would maybe test it by picking some numbers and making sure that I was right. So, and what numbers are you picking?
Well, I was thinking for pounds, maybe 10 pounds, $10. Oh yeah, 10 pounds, and then I was thinking, even just to make it easy, $10, so it's $1 a pound.
Okay.
The cost of 2 pounds, so that be $2 of potatoes was.
Hold on. What's 2p number of pounds?
Okay, that's going to be 20.
Okay, so now we're in 1990. This is 1980. And in 1990, we now have 20 pounds of potatoes. Cost how much?
They cost half of what they were, so $5.
Okay. So what's the percentage decrease? Now there's one third step here that I don't know if you need to take or not, but you need to figure out the price per pound. So this would be 1 pound per dollar. And this would be 4 pounds per dollar, right?
Uh-huh.
So this is 25 cents a pound. This is $1 a pound.
So it increased by 75%.
It decreased by 75%.
Yeah, decrease.
Notice that if you had to increase 25 cents up to $1, you would have to increase it by 300%. So it really makes a difference when you're going up to down or down to up. In other words, if you have a stock that loses 75% of its value, in order to get back to where you started from, you have to make 300%.
Oh, geez.
Yeah, I know. That's a sad fact of mathematics. Okay. The way I was able to see that easily is that I could see that twice as much potatoes cost half as much, so we had undergone a 4-to-1 drop.
Oh, okay.
And it didn't matter whether it was $4 to $1 or $1 to 25 cents. It had dropped from 4-to-1, and that's a 75% drop. So. Oh, I see. You know, on the practice exercises, I don't think they give you this direction. I don't remember seeing this on any of them.
Yeah, I don't really either.
And it's nothing that we didn't know already.
No, probability. And of course, is 0 considered a positive integer?
It's considered an integer, but it's not positive. It's neither positive nor negative.
Okay. Well, let's see, 9 over 1 would be greater. Looks like 2 out of 9.
Let's list our positive integers less than 10.
Okay.
There's 9 of them. Which of those is this statement not true?
Okay, so I did it backwards. There are 6.
Well, let's see. Let's just go through them one by one. That's true. That's true. False. Right?
Uh-huh.
False. All the rest of them have to be false. So you were correct. That's what you said originally, right?
Yes.
I was the one doing it backwards. I had it, I thought all 8 of them were true until I actually looked at the inequality and did it. And then so there was our counting problem.
Oh, I know.
And that was...
I hope I don't have too many of those.
Well, actually, I think they're kind of fun. You seem to be pretty good at them.
Oh, thank you.
When it comes
I don't
time
feel like it.
laying out the possibilities and stuff.
Uh-oh. What is this again? Okay, so we have a total of 12. I don't know why, but these ones stump me. I don't...
Work backwards. What is the worst case scenario?
Well, if the worst would be...
How could you remove marbles such that you would not have one of each color?
Well, you could end up taking out 5 blue to begin with.
Okay, there you go. That's the way you have to solve these.
And then
Okay.
I guess 4 white.
Right. In other words, if our goal is somebody's going to get paid a bonus, if we're running a game show and we're going to pay somebody a bonus for getting one of each color, and we're the ones giving away the money, I want him to get 4 white next.
Yeah.
And he's picked 9 times and he does not have one of each color.
And then as soon as he picks the next one, it's going to be one of each
one
color.
has to be red.
10.
So 10.
Okay. Okay, in this case, let's see, 5 math tests. Okay, so his sum on those tests would be 350. Oh, wait. I was doing that wrong.
What's the secret when doing arithmetic means? What's the secret word? Totals.
Right, and I was going to come up with the total of 350, but I realized that, let's see, if he gets 70 on his next test, so that would be 70 times 6, so 420.
Let's try to do it algebraically.
Okay.
Let's let x, whenever you're doing a word problem algebraically, it's good to start with a variable and let it be whatever his total of first 5 tests. Right?
Okay.
So, what is his average? After 5, his average is x divided by 5. After his 6th test, what's his total going to be?
It's going to be x minus 4.
It's going to be x plus 70.
Oh.
Because x was the total of the first 5 tests.
Okay.
So if he gets a 70 on his next test, his total is going to be x plus 70. And we're going to divide that by 6. And so that's his average after 6. And they're saying that his average after 6 is going to be his average after 5 minus 4. Now we can solve for x. Once we've solved for x, we can solve for x over 5 and answer the question.
Okay.
Okay. Let's go ahead and solve for x here just to brush up on your algebra skills. What's the easiest first step to do to solve this?
I'll probably multiply both sides by 30.
Okay, good. I'm going to take that over there and this over here, merely because that gets it solved the quickest and the easiest. So there's the total. So that's the total of his first 5. So if we divide that by 5, we get 94.
Okay.
And let's think about that for a moment as to whether that makes sense. He's got a 94 average through 5 tests, and he really screws up and drops his score by 24 points, but the 24 points is going to be spread over 6 tests, so it should drop his average by exactly 4, and it does. In other words, if we apply that last, does this make sense test?
Okay.
And in fact, if you really were stuck on this problem and you had lots of time and you weren't able to formulate it, you could do some approximation and guessing. In other words, you could start off by saying, well, we know that if it lowers his score by 4, it must have been about 20 points less than his average. So let's start guessing. Although that's going to be tough because you don't know whether to guess in the 90s or, yes you do, because you know it's, yeah, you'd know exactly where to start. Let's go through that because that might have been a much easier way to solve it.
Okay.
In other words, rather than thinking about totals, which is the first word that always comes to my mind when I'm thinking about arithmetic mean, let's see if we could take a guess. If he scored a 70 and it lowered his total by 4 points over 6 tests, means his average must have been about 20, 24, or possibly 28 higher. We're not sure, but if we start with 24 and work through the numbers, that works perfect. In other words, if you multiply this by 5, you get 470, or whatever I had, 540, and then you subtract 70 from that, you realize you lower the average to exactly 90, and you have your answer. So you can almost back solve this. The trick to back solving it is knowing that the range of numbers you need to check have to be in the 90s.
Okay.
You don't need to check 80 because there's no way that if his average was 80 and he lowered it, the 70 wouldn't lower that by 4 points. It would only lower it by, what, a fifth or a sixth of the amount. We're not sure, but it's one of those two. Well, let me see if I can blow this up a little bit. You want to go through these next 3 questions?
You know what? Let's just skip those ones.
Okay, because this one was clear enough that I think I could have done it, but maybe not the best use of our time. No. Shaky Dave was here.
Okay, that one looks like it's missing information.
Oh, that must pertain to the graph.
Oh, okay, because I'm thinking, what?
Yeah, I went through the exact same process. There's something missing. There's something missing here. You read that whole thing?
Yes.
This is a clever problem, I think.
Okay, so it's going to be pretty much a squared plus b squared equals 10.
Not. Notice that, what's the Pythagorean theorem say? For a right triangle?
I thought it was, yeah, a squared plus b squared equals c squared.
Okay, so a squared plus b squared is equal to 100. Notice this is a plus b quantity squared. What is that equal to?
A squared plus a 2ab plus b squared.
Okay, so that's what they want the value. So it's obviously going to be 100 plus 2ab. Well, what is 2ab equal to? First of all, the area of this triangle is 20. Area equals 20. 20 equals 1/2 AB. See where I'm going?
No.
Okay, if 20 equals 1/2 AB, if we can figure out what 2AB is, we'll know the area, we'll know what a plus b quantity squared is. In other words, this is equal to 100 plus 2AB, right? Because a squared plus b squared equals 100.
Okay.
Okay, so what they're seeking is 100 plus 2AB. So we need to solve for 2AB. Well, solve this for 2AB. Make that look like 2AB. What do you have to do?
Multiply both sides by 2.
About 4. Notice that if we multiply the right side by 4, it becomes 2AB. And the left side by 4 becomes 80.
Okay.
Okay? So a plus b quantity squared must be 100 plus 80.
Okay. I think I got that.
Okay, the tricky part here is that a plus b quantity squared is not a squared plus b squared. But we know what a squared plus b squared is, so the only thing we need to solve for is the middle part, 2ab. And we're able to get 2ab from the fact that the area of the triangle is 20. And area is always a function of a and b. Wonder if this is a 3. Does that look like a 5 to you?
That's what I was thinking,
Okay.
but I'm not sure.
I don't think it matters, does it? What is the average of those 3 numbers? It is a 3. It's got to be. For one thing, it makes more sense in the context of the problem for that to be a 3. How do we figure averages?
It'd be 3 plus 3 over 3 root 30, or root 30. Yes, add them all and divide them by 3.
There you go. Now, how can I simplify this?
You can factor out the 330.
Turn it into three numbers. In other words, turn it into partial fractions. We've got this part here is the first number, plus this part here, plus this part here. What is 3 to the 30th divided by 3?
3 to the 29th.
What's our answer?
E.
Okay. Oh, I love these problems. They can be devilish. Let's have a look here. I haven't done this test, incidentally, which sometimes can be beneficial for you. Because sometimes if it's a hard problem and I don't know how to do it, I'll explore different ways, and that can be useful to know.
You're just so good at this. It's been so long since I've worked on math, I feel like an idiot.
Oh, let's see what we got here. 4 large semicircles and a large semicircle.
Okay, so I want to figure out what the large semicircle is and deduct all of the smaller circles.
Well, we want the perimeter of the shaded region. So what does that mean? We need this distance here. 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 And we need this distance here.
Okay.
That should be a piece of cake. Let's start with which one? Let's start with the small ones or the big one?
The big one.
Okay.
No, small ones.
Well, the smalls might be easier because we know their total radius. Whereas the big one, we're going to have to figure out what the radius or the diameter of that whole thing is. So what is the half circumference of this smallest circle?
Let's see, since it's got a radius of 1, it's 2 pi divided by 2, so pi.
Okay, so that's part 1. That's the smallest. What's the second circle?
It's going to be 2 pi.
And the third circle?
9 pi. Is that right?
Yes. And the fourth circle?
Is the 9 pi one right?
Yeah, in other words, we're looking at 2 pi r, but we're only looking at that, so it's always pi r. I'm sorry.
Oh, you know what? It's actually supposed to be 3.
Yeah, we're not squaring it.
No.
It's always pi r. So,
yeah, so
thank you.
yeah, I messed up.
So that's got to be, well, and I didn't catch it.
And then 4 pi.
Yeah, I got caught up in areas, not circumference.
So did I.
So the total of that is 10 pi.
10. Yes.
Plus we need this one.
So let's see, it'd be 2, it would be 20 pi.
let's see, what's the diameter? The radius of the big circle is how much?
The radius is, oh, it's actually going to be 10.
Right. So that outside semicircle circumference is also 10 pi. Right?
Yes.
Okay, so 20 pi is the total. Interesting. I suppose that this applies universally. This is always the same distance as that. Interesting. Same principle as this is always the same distance as that. Almost exactly the same principle.
Huh.
You'll perhaps come across problems like this that says, what is the perimeter? And they'll give you, you know, that's 20, that's 10, but they won't give you these measurements over here.
And that's because they're the same.
Yeah, so you can figure it out without knowing any of these dimensions.
That's good to know.
Yeah, that's an interesting geometric principle that I didn't realize was universal and applied to circles also. You can do this a couple of ways. I'm not sure which would be easiest for you. You can do it algebraically, or you can pick some numbers. Only difficulty with picking numbers is it might take a while to come up with an A and a B, but maybe not.
I don't know, because that's what I started to do at first, and
It's easier said than done, isn't it?
yes.
Let's see if we can think of some odd numbers. Let's see, if we increase, no, the problem is when you increase a number by 25%, you rarely end up with a number that is 25% less. So let's do it algebraically, since it's hard to come up with that exact ratio, and we need to. We can't come up with an approximation. So if A is increased by 25%, what does that mean mathematically?
It's A times 0.25.
Times 1.25.
Oh, yeah, increased.
Okay. And if we were saying that that's going to be equal to B being decreased by 25%, what do I need to write on the right side of this?
B times 0.75.
Now, what's the ratio of A to B? Let's use fractions here, just for simplicity's sake, because they're going to want it as fractional, not decimal. So how do we find out the ratio of A to B?
It would be 1.25 divided by 0.75. No?
The other way around. In other words, if we want A to B, I have to divide both sides by B. So I'm going to divide that by B and that by B. And now if I want A over B, I have to multiply both sides by 4/5. Getting those to cancel, and now I'm left with just the A over B, and this is equal to 12/20, which is equal to 6/10, which is equal to 3/5. Since they want a numerator and a denominator, we do not want it in decimal form. So, in fact, there's no way to enter this in decimal. I wonder what they do if you put 0.6 right here.
I'm pretty sure they'd give it wrong.
Yeah, I kind of think so also. Because they're instructions. Enter the numerator in the upper box and the denominator. They want the following question as a fraction.
Yeah.
Okay, so probably from the beginning, instead of using decimals, we should have used fractions, I guess. Yeah, because what are you going to do if you use decimals and you come up with some odd-looking decimal like that? Do you know how to turn that into a fraction?
I do, but it's easier just to start with fractions.
I think so too. I mean, if you have the right calculator, there's just a key that'll switch back and forth between the two. But I don't.
Oh, that's nice.
Yeah, but I don't think the calculator you're going to have is going to give you that ability.
No, it's not. It's very basic.
Yeah, so you're better off just starting with fractions here. I mean, yeah, instead of decimal. Okay, that was next page. So that was section 3. I think there's only 2 sections, so that's more than half of the quantitative test. Okay.
Okay, in this case, quantity A would be larger.
Okay.
And this one, they're going to be equal.
Good. Because this is a to the 18 divided by 2. So this is a to the 9th, and this is a to the 9th.
I wish all of the problems would be like this.
Yeah, although this makes me a little... I keep wanting to say this is plus or minus a to the 9th, but it's not. Once they give you a radical sign with no sign, you are to assume that it's plus. Price of a large pizza is 30% more than the price of a small pizza.
I can't see the bottom part of quantity B, the price of a small pizza.
That's it, yeah.
Oh, that's it.
Uh-huh.
Quantity B would be larger. Well, maybe not. It depends.
If we pick some numbers, which I think is the best way to do this.
Well, yeah, that's pretty much what I did.
Okay, so now the question is what's larger, 70% of $13, which is what it is with a 30% off sale, or $10?
Yeah, so $9.10 or $10.
Very good. You're right. You know what? Let's see. First of all, let's see if we can figure out. This goes A, B, C, D, E, F, G. Now I have to make it a little smaller so that I can see the problem. Okay. So we have 1, 2, 3, 4, 5, 6, 7 angles.
Okay, in this case, quantity A will be larger.
Good, because 360 divided by 7 is bigger than the number 50.
Yeah.
Because 350 divided by 7 is 50. Okay, I love age problems because they can almost always be. I've never found an age problem that I couldn't do. I can almost always do them by back solving, but these might be a little different because they're quantity comparisons.
And of course, for me, the easiest way, let's see, in 9 years, Katie will be 4 times as old as she is now. So if she were, let's see, say she's 4 now. And that doesn't work. I have a really hard time with these ones too. I'm not sure why, but let's see.
Well, the track you took is fine, and trying to figure out how old she is now. And trial and error, well, let's see. What's going to be close? If she's 2, in 9 years she'd be 11, but 11 isn't 4 times 2. So she must be 3. In 9 years she'll be 12, which is exactly 4 times 2. So we've figured out that she's 3 by trial and error. You could also do she is now 3. You could also do it algebraically in saying that whatever her age is now is x. So x plus 9 equals 4x, right? In other words, if we wanted to solve that first statement algebraically, it would be, will let x be how old she is now, and in 9 years she'll be 4 times x. And that gets it also. But trial and error isn't bad. So now the number of years until Katie will be 8 times as old as she is now. Well, let's just check what 20 would be. In other words, we don't have to set up a separate equation to figure out what the number of years will be. We could just test either side of 20. So let's first check 20. Well, in 20 years she'll be 23. Is that 8 times more than she is now?
No.
Slightly less.
So quantity A has to be larger.
Yes. Because you have to increase it. In other words, in 9 years, or in 21 years, she'll be 24. So quantity A would have to be 21. Yeah, okay. And that also could have been solved algebraically. But actually, I think I like, rather than solving that algebraically and then comparing the answer to 20, I kind of like just trying 20 and then figuring out which side of it you're on. You know what I mean?
That one, no.
Well, in other words, we didn't solve that. Algebraically, I would have said she's 3 right now plus x, and that's going to be equal to 8 times 3, 24. So x has to be 21, so the answer is 21, and then I can compare that to 20. So that's one way to solve the problem. The other way is to just plug 20 in and figure out that that's only 7.8 times as old as she is now. The only problem with doing that way is you have to be very certain that you need to increase this number in order to get it to be 8 times. Algebraic way is a little safer, but most of the time it's not that difficult to deduce which way you have to go.
Okay.
I tell you what, do you mind if we stop there?
Oh, not at all. I didn't realize what time it was.
Yeah, I forgot that I meant to stop 5 minutes earlier. I don't even know if this thing's going to work.
Hopefully it does.
Well, I hope it does, but GoToMeeting might have issues with international calls. I've never tried it. So.
Well, good luck on that, and we'll talk to you next week.
Sounds good.
Okay, thanks.
Bye-bye, Angela.
Bye-bye.